Hello everyone, I am Shashta Akranka. This is the third video in this tutorial series. This video I am going to talk about sequential logic. Before explaining that, we have to know what's sequential logic. Sequential logic is a type of logic circuit whose input depends not only on the present value of its input singles but on the sequence of part of inputs. Its basic concept is this type of thing. It's a memory combination logic circuits and memory locations. Input combination with an input, also input combination logic circuit. Then output, and output is goes to positive feedback and its memory also. This is a normal logical concept. And it has two type of circuits. First one is synchronous and second one is asynchronous. Synchronous circuits basic concept is normal circuits we connect under couplers. Then we call it synchronous circuits, and asynchronous circuits are not connected to clock pulse. Those are the difference of synchronous and asynchronous. Then what are the latches? Latches are also sequential logic circuit is a type of the sequential logic circuit, and it is the memory. It can store some data and it's called memory. Let's do latches do their type of memory. Then we move to SR latches. We can make SR latches are two typically. Then NAND gate SR latches and no gate SR latches. First I explain NAND gate SR latches. NAND gate SR latches we show, and this is a basic circuit of NAND gate SR latch. It's represented this type of. Then this is the timing diagram in the SR latch and bar chart. I'll explain two things in the practical session. Then those circuits has active high and active low. Active high means those latches set and reset inputs as low. Low means ground level. Then when we input set and reset to 0 value, it's an active high circuit. Active low circuits are set and resets have 1. Those active low circuits. Let's move to the practical session and I'll explain SR NAND gate latches. This is a sequential logic circuit and logic tool. Then we have to go to NAND gates. We have to make two inputs and connect to output. And we have to connect this place in one input and second input in here. Then now show how to implement this circuit. This is the SR basic concept. SR latch. This is a latch. So typing when I inputting a 1, you can show change in output. I'll label that first one is S. First one is S, and this one is R. So and output 1 first one is Q, and second output is Q bar. When 0, those two values in 0, you can show both inputs are 1, but it's not a right value. If we using this Q is in a 1, Q bar is must be a 0. Those two values must be different value. Then when we input a 0 and 0 for SR latches, this is an invalid location. When we input set for 1, you can show Q bar is 1 and Q is 0. This is one situation in this latch, and second one S is 0 and reset is 1. Then you can show Q is a 1 and Q bar is 0. Then we will show what the situation those two inputs in 1 show. You should not change that value. Then I change again in the set is reset is 0 set is 1, Q bar is 1, and input set and reset both inputs are 1. Not change in output. Then this location we call memory location. Okay, and it's I mentioned that this is memory location. In both inputs are 1, it's called memory location, and both inputs are 0, it's individual invalid location. Most of times when we created the circuits, we have to know and we have the good knowledge about these two locations. Okay, next move to the no gate latches. I'll explain no gate latch also. I'll remove that. And I'll create no gate, two no gates. I need two no gates. One to output. We have to get two inputs, and it connect and to input two values. First one, second one input, another input, output, and another output. Now I'll show how to implement this circuit. Then both inputs are 0. Now if I input is first one, I have to label S, S, and second one is R, this is a Q, and this one is Q bar. Now again, this must be those outputs are not like the same to output. Not must be the same, but those two outputs must be different. Then I'll input the reset for 1. You can show Q is 1. Then I reset 0 and set is 1. You can show Q bar is 1. Then I'll input those two values and what the implement in this circuit. Show not any value. Therefore, this is the invalid situation of this circuit. Then I show that set is input. You can show Q bar is 1. Then you change those two values are 0. You show it's not change. Then I again input reset for 1. You show Q is a 1 out. Then I again reset also 0. Reset and set also 0 values. Then you shall not change in this cell. This is the memory location in this cell, and 1 is an invalid location of this circuit. This is I mentioned memory location and invalid location. Then we will move to the D latch. D latch is another type of SR latch. It's different. It has only one input. I remove this input and I connect it and it connected. this input. Then you show what the input and how to do this. When I input 0, Q is 1. When I set for C1, Q bar is 1. This so it's two only two values, that's 1 and 0. When I input the set for 1, Q bar is 1. Set for 0, Q is 1. This is the delatch execution and delatch. Next move the flip-flop. Flip-flop are advanced type of the SR normal latches. It's also memory, typical memory. Its basic concept is SR latch and its input in the clock signal is the clock values. Then SR latches, this SR latch is synchronous SR latch. Then clock flip-flop, SR flip-flop. It is some discrete in the sequential logic circuits. To have disabled SR flip-flop that only change state when clearly obtained and generate the condition. Then I'll show its implementation and wait. I'll remove this one. I'll remove delete and it into 12 minutes. 12 minutes. Two inputs. Set two inputs. And those two inputs into output. And output one. First output and second output. And we have to connect this to AND gates. It's also two inputs, have two inputs. This one input and two input. Then it connected to this circuit and this one connected into this circuit. Okay. Then these two inputs connect together and it will give to clock pulse. Two inputs and clock pulse. This is the clock signal. You can show those things. Then clock signal and this is the circuit of SR flip-flop. Then I implement, then I input 1 and 1. You can show not change. Therefore, this clock signal is 0. Then I input clock signal is 1. You can show and any error. Therefore, that's any error in this circuit. Therefore, I simulate resets 1 and again I simulate circuit. Then I input 1. You can show not a 1 and 1 type of this. This is 1. You can show this output is change and then it's 0 and this one is 1. Another output is 0. So this output is 0 and this one is 1. Then you show and I 0 this level input those two. When I input those will not change anymore. Therefore it's a memory location and those two inputs are also 0 and when I input clock pulse in 1 it's also memory location. Therefore it's not change. You should now show it's not change. Therefore when input 1 and 1 it's a 0 is 1. You show that's an error. Therefore this is the invalid situation. You show this is an invalid situation and those two memory locations. This is the important parts of this SR flip-flop. When we created a circuit, we have to know about those memory locations and invalid locations. Therefore, it will help for creating a good circuit. Then we move to JK flip-flop. JK flip-flops are most important flip-flop. Most circuits we use this flip-flop, and this is a basic representation of JK flip-flop, and this is the basic circuit in JK flip-flop. I'll show this JK flip-flop. Before I'll show the circuit, and I'll explain JK flip-flop memory locations and normal one. And memory locations is this is the memory location. Memory location when you put in the everyone is zero, you can show this is 0 0. Clock pulse is 0. 4 values as clock pulse is 0. So this is a memory location. Other values we input any value, not care about the most values from circuit, and input is memory location. This is the memory location. Then those two values inputs are 0. When inputting clock pulse is 1, not care about that. It's also memory location. But this JK flip-flop has very special situation. It's a toggle. It's toggle and it's a typically invalid situation. When inputs those three values also 1, it's an invalid situation. But it's a typically this it has a, this is the unique value of this toggle, this circuit. Its output time to time change. When someone is in the one output, then that output is 0 and another output is 1. That's the unique type of this JK flip-flop. I'll show you the JK flip-flop also. JK flip-flop has three inputs. Therefore, I simulate to simulate a reset simulator and simulator again. I modify this to this one because I is for that. Then I remove this input and remove this input and give three inputs for that. This also three inputs. Then I connected this one for this input, this one input and the input. Then I connect this one and this output and second output and this place. Okay, now show this is the JK flip-flop, and I simulate one and track and enable can show clock values 1 and 0. I'll show you toggle situation, then I import show stop, I stop simulate and the track enable, then I input two values are 1 and simulate track once. So once track enable, and you can show the error message reset. Then I input this value and we input clock pulse is 0. Then we use those two values is 1 and 1 0 1, and you show this area, and when I change those two values you have to show this area output. Okay, those two inputs also 1 not change, 0 1 not change, 1 and 0 not change. Because of those are, and the one is those two values are 0 and clock input 1, you should not change. Those four situations are memory locations in this circuit. Then those three inputs are also 0, it's also a memory location, and 1 and clock pulse is 1. Then you show one output is 0 and another output is first input is 0, then second input is 1. You show second first input is 1 and second output is 0. Then change that. This is the not a toggle state. This is the toggle one. Toggle means these values are changed. You show and you can show this is a error. I say this is a error in this uh, flip flop. Therefore, I used another JK flip flop. I remove this circuit and I show you toggle situation in this JK flip flop. We have to mention JK flip flop. This is circuit in JK circuit in default. Give from this Luxem tool. I use that JK flip flop and two inputs on two inputs and clockwise input. We have to do that and so the clock input and two outputs in here. You can show I'll show you this output one output and second output. Then toggle situation is two inputs are one and clock pulse also must be one. Now show then you can show clock pulse change to time change. You can show those both inputs outputs also change. Now, this is the toggle situation and toggle location in JK flip flop and it's very important to us for creating the circuits. Therefore, I'll move this slide and this is the sequential logic circuits and this is the concept of basically concept of sequential logic circuit. Thank you.